Hello everyone, welcome back again to Global Kids Connect Mathematics. So last time we took a look at percentages, and for today's class, we will do a similar but slightly different concept regarding the topic of ratios. I think we can jump straight in. Yeah, today's class will be on the topic of ratios. And then we'll go through our first concept of today, which is basic ratio calculations. And so the definition of basic ratio calculation is that ratios are often used in proportions where two ratios are set equal to each other. And some key skills is to solve proportions using cross multiplication. Uh, and so we could say that if there are two fractions that are equal to each other, such as a over b and c over d, as shown here, then we can actually rewrite this equality as a cross product. And the reason we call this a cross multiplication is because we multiply in a cross shape. And so the proof behind this is that we have this equal sign that we can multiply. Let's say, for example, we want to get rid of b in the denominator for the left fraction, then we can multiply b on each side. If we do that, then it becomes a equals d in the bottom and c times b on top. And then we have another denominator that we want to get rid of, the d on the right. And so we multiply each side by d so as to get a new equality of a times d equals b times c. And so if you take a look, then we have proof that if we have a equality with two fractions, then we can use cross multiplication, multiplying the two numbers or variables on the cross on each end of the cross, and then multiplying these together to get a technically same but a differently expressed equality in the form of this. And so cross multiplication will come up quite frequently during our example questions and practice questions, and so it's good to get familiar with it. And so I think we can move on. So let's take a look at how these methods and these problem-solving skills can be utilized in actual practice questions. And so we have our first very basic example question. So if we have the equality of 2 over 5 equals x over 60, what is the value of x? Now, there's multiple ways to do this. You could either change the left side fraction to have a denominator of 60 and then find x that way. But then let's try to use cross multiplication to get used to it. And so, uh, like I explained, you can multiply the two numbers in a cross like this. So as to get 2 times 60, because there's 2 on one side and 60 on the other, equals 5 times x. And so we can quickly solve this. And so we can say if we divide each side by 5, then we can rewrite it as x equals 2 times 60 over 5, which equals, if we simplify, we can get rid of the 5. So it's 2 times 12 equals 24. And so just a very basic example on how we can use cross multiplication in ratio problems. And yeah, I don't think anyone would have a question regarding this one. Yeah, okay. And then just a slight detail to go over right before we move on is that there's different ways to express ratios. Some questions express it as, let's say, 2, the ratio is 2 to 3. So this is I guess, ratio that most of us are familiar with. However, this can also be rewritten in certain contexts and depending on the question type, it can also be written as 2 over 3. And so it's just a small thing to remember, just as not to get confused, because even if it is a fraction, and if the question gives you a fraction, it's still technically a ratio, and you can use the same ideas and concepts. And so now that we got that out of the way, I think we can move on to a practice question. And so the solution is as it is. And for tips for this kind of question is to always start by cross multiplying to eliminate fractions, and then to solve for the unknown variable step by step in order to avoid mistakes. And so we have another practice question. So the same kind of question, but we can take a look at it again. Again, if we have two fractions that we can cross multiply as such, so that we can get 3 times 21 equals 7 times y. We can divide each side by 7 as to get y equals 3 times 21 over 7, which equals, if we simplify, 9. And so, same method, nothing too different. And so I think we can move on. Yeah. And so we took a basic look at ratios in general and how and cross multiplication. And so we can build up on that and talk about proportional relationships. And so proportional relationships are when two quantities are proportional if they maintain a constant ratio expressed as y equals kx, where k is a constant of proportionality. So what this means is that if we are given two quantities, it can be anything. They are said to be, and we can term them as being proportional if they maintain a constant ratio. And so what we mean by that is if we have A to B, then they have a ratio of A to B. But then if we have another two quantities, let's say 3A to 3B, then it is still proportional because they have a constant ratio. And this is because we can divide each side by 3 so as to get A to B, which is the same thing as our first ratio. And because of that, we can say that there is a constant ratio, and therefore, uh, these two quantities are proportional. And so we can say, and most of the time they can be expressed as a sort of a algebraic linear equation in the form of y equals kx. We'll take a look at that and how that is used in an example problem. Before that, let's take a look at key skills. So key skills involve identifying k from given data and using it to find any unknown. So whatever the question asks of us to find, uh, we most of the time will need to find what the constant value k is before that. And so we'll take a look at an example problem utilizing these concepts. So the problem states the table below shows a proportional relationship between x and y. What is the value of c? And so we can see that there's a table with x on the left, y values on the right, and we're given numerical values except for here, where we are given a variable c of an unknown value, and so we have to find what value of c is. And so the most important fact is that the question says the table below shows a proportional relationship between x and y, which means that the ratio between x and y, so the ratio x to y, is always constant. So using this, we can compare the ratios. So first one is we have 3 to 24. But then we can simplify this so as to get, if we divide each side by 3, then we get 1 on the left and 8 on the right. And important thing, when simplifying ratios, simplify by the greatest common uh, divisor or divider. And in this case, it was 3 because if we divide 3 by 3, then we get 1, and 1 is the smallest value we can simplify into. And so we can take a look at the second one as well. If we have the ratio 8 to 64, then we can write it as. Also, if we divide each side by 8, then we get 1 to 8. The same goes for the third ratio, 14 to 112. If we divide each side by 14, we get 1 to 8. And so we have our final ratio, C to 56. However, this must be equal to 1 to 8 because it is always proportional. And so here you have to calculate what C is. You could calculate just by analyzing that if you multiply 7 to each side of the right ratio, we get the right side, this 8 becoming a 56. And so automatically C would equal 7. But then sometimes there are ratios that are quite more complex and you can't automatically see what you have to multiply. In that case, I want to show you a tip for finding ratio equalities. So we have two ratios in the form of this. But then, like I previously said in our concept before, we can rewrite ratios as fractions as well. And so if we do that, then this equality of ratios, the ratios will become C over 56 equals 1 over 8. And so if we have fractions instead of these uh, colon ratios, then we can now utilize cross multiplication in order to find C. And so we can do the same thing as we did here last time and cross multiply so as to get 8 times C equals 1 times 56. And so if we divide each side by 8, then we get C equals 56 over 8, which equals 7, our answer. And so sometimes if you're comparing, let's say, ratios in the form of this, forms of having colons between, then you can re-express it as fractions and then cross multiply to find whatever variable you have to. Uh, Another way is there are multiple ways to kind of visualize or think of cross multiplication. You can actually not change it into a fraction if you want. Keep it in this form and only multiply the inner side with each inner side and multiply the outer sides. If you were to do this, then you get the same relationship as here. 8 times C equals 1 times 56. And then you can solve for C again to get 7. So there are multiple ways to look at and solve uh, equalities involving ratios, and it's really up to you on which one is more, I guess, easier for actual question solving. And so, does anybody have any questions regarding this problem? It seems like not. And so we will move on to our next question. So as always, solution is the same. And then for tips is to look for a consistent ratio between x and y by dividing each of y by its x to find a constant k. Then use it to solve for unknowns. Okay. So my method was also valid, but then there's another method, the last one. Let's just take a quick look at it. So in the solution I wrote for this problem, I utilized the concept we took a look at of using a kind of a linear equation y equals kx. And so let's take a look at how we can solve the same problem, but in a different method using y equals kx. And so let's just take a look at the solution written. And so for finding k, we have the equation y equals kx. And so we can rewrite this by dividing each side by x as k equals y over x. And so if we do this, then we can use the data in the first row right here in order to find k, which is 24 over 3, which is equal to 8. And so we found quickly what the value of k is. And so we can plug this k value back into the equation to get y equals 8x. And from here, you can check that 8 is a valid answer by plugging in the other data values. And then at the very end, we can plug in the data for x equals c and y equals 56 in order to check for what value c is. And so if we do that, then we say that y value of 56 is here. And because 8 was our k value and the c is our unknown variable, we get this equality, and then we can divide each side by 8 to get c equals 7. And so I covered a large variety of problem-solving methods. And so you can just pick the one that you're most familiar with and most comfortable for when solving actual questions on your digital SAT. And so I think we can move on because I think everybody kind of understood uh, each method. And so, oh, Let's take a look at another proportional relationships practice question. And so the problem states if y is proportional to x and y equals 15 when x is equal to 3, what is y when x is equal to 10? And so for this question, let's utilize the concept of what we just did of the linear equation y equals kx because we know that it is a proportionality problem and that x and y is always proportional. And so if we have this equation, then we know our first data value of x when x is 3, y is equal to 15. And so we can plug this data into our linear equation to find value of k. And so, like I said, k is equal to y over x, which is equal, in our case, 15 over 3, which is equal to 5. And so we can rewrite our linear equation as y equals 5x. And so now we have to find a y value when x is equal to 10. So simple enough, we just replace our x variable with the number 10 so as to get 5 times 10 is equal to 50. And therefore, when x is equal to 10, we can say that y is equal to 50 due to proportionality. Anybody have any questions for this one? Okay, I don't think so. And so we can move on. And so our third concept of today is regarding ratios in word problems. And so ratios are used to compare quantities in real world contexts like populations, recipes, or rates. And so we take a look at a couple of context questions. And some key skills is to set up the ratio, define variables, and solve. So basically what we did until now is just that the problems will be a tad bit more difficult because we have to analyze a context. But they won't be too different, so we'll take a look right away with our first example problem. And so the problem states the population ratio between countries A and B is 7 to 12. If the total population of countries A and B is 76 million, what is the population difference between the two countries? And so there's a couple of things that we have to first analyze is that the ratio of countries, of the population in countries A and B is given. And so we can say that the ratio of population A to B is equal to 7 to 12. And then we also know that the total population of countries A and B is 76 million. And so we can say that A plus B, if we were to say that A and B were the population numbers, then that would equal 76 million. Uh, just for problem solving sake, we'll just put the unit as millions and just keep the number itself as 76. We can change the unit to per number of persons later on. But just to make our problem solving easier, we'll keep it at 76. And so using these two equations, we can actually find each value of A and B. And so first thing we have to do is to change our ratio equality here to a slightly more useful one. So like I explained for our previous practice questions, we can actually utilize cross multiplication in order to get another expression of this first equation. And so if we were to do that, then we can say that this becomes uh, you could change it into fractions and then cross multiply, like I explained. But then if you want to save just a couple more seconds, then you can just multiply the insides together and the outsides together as well. And so if we do this, then we can write that 12 times A is equal to 7 times B. So we have a slightly more useful expression for our first equation, and then we can put in our second equation right below as well. So now that we have these two equations, uh, we can actually replace either A or B in the second equation with a same variable from the first. So what I mean by that is we could say that we can change the first equation so as to say B is equal to 12 over CA. And so now that we know that B equals 12 over CA, we can replace B in our second equation with this 12 over 7A. And so if we were to do that, then we can say A plus, uh, excuse me, 12 over 7 times A is equal to 76. And then we can add these two together so as to get, uh, it'll be 7 on the bottom, 7 plus 12 times A equals 7, which will be uh, 19 over 7A equals 7. And so it's the answer I feel will have to be a decimal, but then it will be fine. And so if we divide each side or multiply each side by the reciprocal of 19 over 7, then we get 49 over 19 for A. And so now that we know this, we can replace the A variable within either side of the equation for the first equation or the second equation. Let me just clear it up a bit. And so let's say we plug in this A value that we just got into our first equation here so that we can get 12 times 49 over 19 is equal to 7B. And so we can solve each side for B by dividing each side by 7 so as to get B equals, if we divide 7 on each side, then we can get simplify the 49 into a 7 so that we get 84 over 19 for B. And so this kind of checks out because if we use the ratio given here, that A to B is 7 to 12, then B must be a greater number. And so, and from the values that we got, then we can confirm that B is in fact larger. And so our final step for solving this question will be to find the population difference between the two countries. And so let me just rewrite A on top here. Excuse me, let me write it a bit better. A is equal to 49 over 19, and B is equal to 84 over 19. And so our final step will be to find the difference between these. So A minus B or B minus A, but then we're going to absolute value whatever we get so that we don't get a negative value. If we do this, then it is 84 minus 49 over 19, which is equal to 35
35 by 19.
over 19 million people. And so, if a similar kind of question was to come up in the digital SAT, I would I would guess that the final answer will be a whole number rather than a fraction. But in the odd case that the answer is a fraction, then obviously you will write down the fraction value, or depending on what the question asks for, and if it asks for a decimal to a specific place, like the 10th place, hundreds or thousands, then you would just follow the instructions given on the question themselves. And so, uh, yeah, does anybody have any questions for this one? It was a kind of a lengthy and complex question. And so, any questions I'll be open to answer.
So,
Yes,
if we take the ratio,
yes.
and because the ratio is always equal to A to B, and
Mhm.
it's just a division as a fraction, as you're told. So you can do like multiply both of the numerator and denominator with a common x, because we don't know what the x is. And if we take A equal to 7x and B equal to 12x, they asked the difference between it, but they also told the sum of it is 76 million. 7x plus 12x equal to 76. We get 19x equal to 76 and x equal to 20, x equal to 4
Uh,
mil. And because they ask the difference, we can do b minus a, 12 minus 7. and we'll get 5. 5 into 4 is 20 million.
Okay.
Yeah.
Sorry.
Yeah. Hmm.
Alex. Name is Alex, right?
Yes.
Okay. I do not know. Okay, I do not know what you did here, but the the answer is supposed to be 20 million. I thought that you would
Mm.
add this and the 12, and it will give you 19. Then you kind of do like the percentage kind of thing. Seven part of our whole
Ah,
times the total. So
I
7 over
see.
19 times 76, and that will give you
Mm,
28, right?
I
12
see.
over 19 times 76 will give you 48. Then you find the difference, which is 20 million. I do not know how you got all
Ah,
this that
okay.
you got.
Yeah, thank you everyone so much for pointing out my mistake. Apologies. I see where I've made my mistake. So, yes, the answer will be 20 million if your calculations were to be correct. And so, let me try it again. Excuse me. And so, yeah, I was wondering why I was getting a fraction for the answer, which was kind of more complex than I remember this question being. Uh, yeah, let's take a look again. Silly mistake. I wrote 7 instead of 76, and that's where the problem arose from. And so let's go back, and then so just to remember what we just did until this step, we changed the ratio into this equality, and then we replaced b equals to 12 over 7a. And so we replaced b with 12 over 7a, so that we got, once again, 19 over 7a is equal to 76. And so if we were to uh, isolate a would be 76 multiplied by 7 over 19. And then this can be simplified. So we can divide the denominator. The denominator will become 1, while this 76 will become 4, because 76 was 4 times 19. And so we can say that a is equal to 28 instead of the complex fraction that I mistakenly wrote. And so we got a much easier value for A. So if the population for country A is equal to 28 million, then we can plug this A value back into the ratio. And so we can plug it into the first equation or second equation, or just to think of it more simply, the ratio between A and B must be 7 to 12. And so if A is 28, then we can see that it multiplied 4. And so we should also multiply 4 to the 12 so that we get 48 for a proportional ratio. If we do this, then we get a B value of 48 million. And so, final step, we find the difference between the two countries. And so we get 28 minus 48, which will be negative 20, but then we absolute value it because it's the difference between populations, so as to get our final answer of 20 million people. And so this will be the correct method of solving. And so uh, thank you both. Thank you to you both for pointing out my mistake. Uh, I'll try to make sure it doesn't happen too much. Yeah. So so this will be the correct solution. And so if anybody has any questions regarding this, but then it seems that you both found the correct answer in your correct solutions. And so I think we could move on to our next question. Okay, then we can move on. Let me just check the time. 33, okay. Then I think we spent a good amount of time with this question to understand all our topics for this concept. And so we can move on. Uh, the practice question you can solve on your own. There is a solution that I've written here. And so you can follow it after class whenever you have free time. And so our next concept, if we're moving on a bit quickly, is ratios with multiple variables. And so until now, we took a look at ratios with just two numerical values, A to B, 2 to 3, or such similar ratios. But then there are also ratios that have more than two quantities. And some context where this happens is questions in context questions regarding budgeting. So anything related to money or any form of cash and spending, there's usually ratios with multiple variables as well as mixtures. So mixtures, if there are context questions regarding uh, making bake a cake or a bread using different kinds of uh, ingredients, then that's also ratios of the amounts that are required to use. And so it depends on the question. And then some key skills to remember is to sum the parts and divide the total accordingly. So what this means is that if we are given a ratio, let's say A to B to C is equal to 2 to 3 to 4. Then let's say if the total amount of A plus B plus C was to equal 18, then if we wanted to, for example, find the value of B, then first of all, we would have to sum the parts. So what I mean by this is to sum the numbers of the ratios themselves. I remember the ratios, most of the time it is beneficial to work in a simplified form. If not, you will still get the same answer, so worry not. But then I would recommend, as a general rule of thumb, to always simplify. So coming back, if we sum the parts, then we get 2 plus 3 plus 4, which is equal to 9. And then we divide the total accordingly. So as to get, if we divide by the total, then it's 18 divided by 9, which is 2. So what this 2 represents is the amount that must be multiplied to this entire ratio to get the actual values for each of our variables. And so if we were to multiply 2 to each side, then we get the new ratio of 4 to 6 to 8. And so these new values for the ratio, represent the actual A value, the actual B value, and the actual C value. And so this is what is meant by a key skill being summing the parts and dividing the total. And so any questions for this concept before we move on? Okay, then so let's take a look at an example question where we utilize this. And so our example question states a mix has A to B to C in the ratio of 2 to 3 to 5. If the total mass is 20 kilograms, how heavy is B? And so, like I explained during our example question for the concept, we use the same method. So summing the parts and dividing the total. And so if we have the ratio A to B to C is equal to 2 to 3 to 5, then we can say that if we sum the parts of the ratio, so 2 plus 3 plus 5 will equal 10. And so if we divide the total, which is 20, by our sum of the parts, which was 10, then we get a value of 2. And so if we do this, then we can multiply this original ratio by 2, multiply by 2, so that we get a new ratio of 4 to 6 to 10. And so this new ratio represents the values for A, B, and C, and we are interested in the value of B, which is this middle value here. And so we can say that B is equal to 6, and the unit being kilograms. And so we can quickly solve for a single variable when we're given a ratio for each of the variables, as well as the sum of the actual values. And so any questions for this one? Okay, I don't think so. Yeah, so we will move on. So fairly simple for our example question. And then a tip is to, as I always said, add all the parts of the ratio to find the total, divide the given total by the sum, and then multiply to the parts that you need. And so let's take a look at another question regarding this concept. And so the problem states Alan earns $45,000 a month. He plans to budget his income into four different categories: tax, rent, food, and others at a 3, 2, 4, 6 rate respectively. How much money would he spend on food in a year? And so we have four variables now instead of three, and we are also given a total of 45,000. And so slightly different, but then the idea is the same. So we solve it in the same manner as we did for our previous question. So always step one is to add the parts. So sum the parts. And so if we do that, 3 plus 2 plus 4 plus 6 is equal to 15. And so because we're given the total of 45,000, we divide this total by the sum of parts, which is 15, so as to get 3,000. Yeah. And so this 3,000, as always, we multiply back into the original ratio. And so you could multiply each side, but then if we take a look, how much if the of what the question asks for, the question asks how much money would he spend on food in a year? And so the only ratio that we will be interested in is if we take a look back here, food was the third variable. And so we are only focused, if we have the ratio here, we will only be focused on the third number, 4. And so we will multiply this 3,000 that we got into 4 so that we get 4 times 3,000 is $12,000. And so final answer would be that Alan would spend a total of $12,000 each year on food. And so, yeah, basically the
Sir,
same method. Yes.
sir, they asked he earns 4,500 a month and he separates it
Ah, okay,
into
I
four
see.
categories. So we
Yes.
actually calculate.
Oh, excuse me. I think you got muted in the middle, but then I understand what you're saying. Sorry, another mistakes. I think I'm a bit tired today, making silly mistakes. Yes, like Srikar pointed out, the 45,000 total is for a month, and but then the question asks for a year. And so a very small detail that can totally make your answer incorrect if you miss it. And so good job, Srikar, for finding this out. And so yes, this 12,000 is the money spent on food each month only. But then we require food per year. And so because we have to change the unit from months to year, and so we multiply by 12. So the actual final step will be 12 times, because there are 12 months in a year, with $12,000. So as to get $144,000. So the actual final answer would be not this top one, but then on the bottom here, $144,000 on food per year. And so, yeah, I think today's class, not only regarding uh, the actual topics of ratios, but then it's a good, I feel it is a good lesson on always reading your questions carefully and also always double checking your solutions if you are able to have time to do so. And so, yeah, uh, before we move on, any questions for this one? Okay, I see. And so, yeah, quick, I guess, tip for taking the digital SAT mathematics is that, and just for the digital SAT in general, is that in my personal experience within taking the exams, I felt that the condition you have on that day is very important. And so, there are students that, study rigorously on right until the day before. And then some students even study until midnight on the same day. But then, in my personal opinion, I would advise you to not. I would advise you to get as much sleep as possible for your exams, to not make any simple mistakes like I have during this class. And so, just a general tip for if you're planning to take the exam in the upcoming months. And so, if we got that out of the way, I think we can move on to our next concept, actually. And so, yes, the final answer will be 144,000. And then we've come to our final concept of today. I feel it is a uh, advanced use of ratios. We're combining with the concept of ratios to geometry this time. And so we'll talk about the concept of ratios in geometry. And so the definition is in similar figures. So what I mean by similar figures are uh, geometrical shapes which have the same or similar shape. And so if we get a cube, for example, each side of a cube it has the same length. And then if we have a bigger cube with a longer side length, but because it's still a cube, the ratios of each side of the lengths, so whether that be uh, this side, and the height, the ratios of these three, A, B, and C, is 1 to 1 to 1 for a square. And so the ratio for the bigger square will also be 1 to 1 to 1. And therefore, we can say that these two shapes are similar. And so this works for both a two-dimensional and three-dimensional shapes. And so let's say, for example, we have a rectangle here with a height of 2 and a length of 5. And then we have a larger rectangle with a height of 4 and a length of 10. You can see that the ratio of height to length is the same for each side. And therefore, we can say that these two geometries or these two shapes are similar. And so this is what is meant by similar figures, just to get you kind of familiar with it. So if we have similar figures, similar geometries, the ratios of lengths, areas, and volumes follow to these specific rules. So if we go back actually to our rectangle example on the right, then you can see that the ratio of the lengths in general were 1 to 2 for the smaller rectangle and the larger rectangle, which coincides with A to B. So if we were to say that uh, the length of the smaller one was A and the length of the larger rectangle was B, then A to B or 5 to 10 will equal 1 to 2. The same goes for the height. And because this ratio is constant, the shape is subsequently also similar. So we use the combination of similar geometries alongside ratios to prove this. And so if we know that the length ratio is just the ratio of the lengths of the same, I guess, side. So if we talk about the same side, but then different values, then that ratio will be the length ratio. The area ratio is different in that we square each side of the value. And so instead of having 5 to 10 for area value for these two rectangles, we say that it's 5 squared to 10 squared. And so if we rewrite this, it's 25 to 100 or 1 to 4. And so we can see that the area ratio is different to the length ratio. But then, like it's represented in our concept here, the area ratio is just the square of the length ratio. And because we previously saw that the length ratio was 1 to 2, we square each side and we get 1 to 4, which is the area ratio. And then uh, you can do the same for the volume ratio. So if the question asks you for the ratio of a volume, or if you need to find the volume of a larger or smaller shape, then you just cube the length ratio itself. So as to get a to the power of 3 to b to the power of 3. And so this is a quick explanation regarding the ratios in geometry for length, area, and volume. And so I think we can take a look at a actual question that utilizes this concept to get a better understanding. And so our problem states volumes of two similar cubes are 8 to 27. The smaller cube side is 2. What is the larger cube's side? And so automatically we're given a volume ratio. And this volume ratio is 8 to 27. And so, and the question also says that the smaller cube side is 2 centimeters. And so we'll just keep this for now. And then the final thing that the question asks for, excuse me, is what's the larger cube side? And so we're given a length of the side and also asked for another length of the larger square side. And so we can kind of, so because what we need to find is in lengths, then we can change this volume ratio into a length ratio. And so if you remember, the volume ratio is the power of 3 or the cube of the length ratio. And so if we root it to the 3, or so if we do this to the volume ratio, which is the same as writing 8 to the 1 over 3 to 27 to 1 over 3, then this can be rewritten as, because 8 is 2 to the power of 3 times 1 to the power of 3 to 3 to the power of 3 of 1 over 3. And so we can rewrite this. If you remember during our first class, we talked about the laws of algebra and the laws of exponentials and multiplication and such. And so if we have a power of a specific number, then we multiply each power with it with themselves. So if we get 3 times 1 over 3, it's just 1. Therefore, the left side ratio for the length ratio is 2, and the right ratio will be 3. And so we found our length ratio here, which was 2 to the 3. And so from here, because we know the smaller cube must have a side length of 2 or a multitude or multiple of 2, and the larger square must have a side length that is a multiple of 3, then we can say that the smaller cube's side, if it is 2, then 2 centimeters to the side length of the larger cube is equal to 2 to 3. Because if we see this, then we can say that the side of the side length of the larger square will equal 3 or 3 centimeters. And so this will be our final answer. And so does anybody have any questions regarding this problem? It seems like not. Then I think we can move on. Okay. And so it was a simple explanation and utilization of different kinds of geometrical ratios. Uh, yeah, and so the solution is shown as such. And the tip for this kind of question is to remember that volume ratios are the cube of the side length ratio. So take the cube root of the volume ratio to find the side length relationship. And so we can move on. Uh, yeah, I think we have time to go through this practice question. And so the problem states areas of two similar triangles are 25 to 36. The smaller triangle's base is 5 centimeters, whilst the larger triangle's base. And so if we have two similar triangles, let's say one triangle that looks like this, and another triangle that's a bit larger that looks like this. And so just for example, our triangles have lengths that are all different. So neither two lengths are the same. Uh, it's usually good to assume, if the problem doesn't state what kind of a specific triangle it is, to just think of a triangle that has three different lengths for each side. And so the area ratio the problem gives us is 25 to 36. And then we are given that the smaller triangle's base is 5 centimeters. So we'll write a 5 here. And we need to find the larger triangle's base. So we can write that as x. And so, as always, we remember the relationships between geometrical ratios. And remember that the area ratio is the square of the length ratio. And so we just square root the area ratio to get our length ratio of root 25 is equal to 5 and root 36 is 6. And so can automatically see that the ratio is 1 to 1 with the actual lengths. And so the value of x, or also known as the length of the base of the larger triangle, will be equal to 6 centimeters, which will be our final answer. And so similar to the previous question we just looked at, but rather than volume ratios, we utilize area ratios. And so, anybody have any questions? I would probably think not because it was pretty similar to the last one. And so, I think we can move on now. And so, this moves us into the first challenge question of today. And so, the challenge question states that Nancy's phone takes 45 minutes to charge from 15% to 40% at a constant rate. So, how long will it take to charge from 0% to 100%? And so, this is a ratio problem. And so we can see that, and it will be a ratio between the time it takes to charge and the percentage that it charges. And so we're given that the Nancy's phone charges at a constant rate, which means if the charging rate is constant, then it is a proportionality problem. And so we can utilize a linear equation, y equals kx. Uh, but then we can change the variables from y and x to, let's say, for example, uh, if y was the percentage charge, then we can put it as a variable p. And then k is just a constant, so we'll leave it as it is. And then we can change the variable x to the time it takes to charge. And so we'll put that as a variable t. And so we need to find values for p and t in order to find a value for k. And so if we were to do that, then we are given the information that it takes 45 minutes. So t equals 45 minutes for a percentage charge from 15% to 40%. And so the phone charge increased from 15 to 40, which is an increase in 25%. And so we can see that when t is equal to 45, p is equal to 25. And so we'll plug this number into this linear equation so that we get we can find a value of k. So k is equal to p over t, which is equal to 25 over 45. And so we can simplify this fraction so as to get 5 over 9. And so the unit for this constant value of k, the unit is very important because it can change depending on whether you swap p and t around. And so because p was percentage, we write percentage per minute. So the constant value k represents the percentage charge for every 1 minute that the phone is charged. And so the question asks for how long will it take to charge from 0% to 100%. So we can see that we can rewrite our linear equation here as p equals k being 5 over 9 times t. And so we know that the percentage that it needs to be charged from 0 to 100 is 100%. So we replace p with 100 equals 5 over 9 times t. And so we can isolate t to get t equals 100 times 9 over 5. So we can divide by 5 to get 20 times 9 is equal to 180 minutes. And so our final answer will be that to charge from 0 to 100%, it will take 180 minutes. And so does anybody have any questions for this one? If not, then I think we can move on. Uh, yeah, so to some important stuff for this kind of question is that if there are anything related to constant rates or constant ratios, then or constant proportions, then always think of the concept of proportionalities and proportional ratios. And that's why we utilize the linear equation method. So just a simple thing to remember for these kind of questions. And then how many challenge questions did we prepare? We have one more. Uh, it is 59. But then if everyone is okay, we can go slightly over time to go over our final challenge question. Yeah, I'll make it quick so as to not get too far of overtime. So let's take a quick look at this problem. So the problem states John and Sarah started driving at the same starting point. John drives at 75 kilometers per hour, while Sarah drives at 60 kilometers per hour, constantly. After 2 hours, John decided to take a 90-minute break, while Sarah continued driving and eventually reached her destination after 90 minutes. After John's break, how long would it take in minutes for John to catch up to Sarah? And so this is as well a constant proportionality related problem because their speeds are always constant. And it's also kind of a broader context question and just basic algebraic calculations. So both John and Sarah start at the same point. And then there's a final destination point that they need to get. So we'll write it as start and finish. And so John drives slightly faster than Sarah. And so if we have John here and Sarah here, then it says after 2 hours. So let's say, for example, if 2 hours pass, then John will be slightly further than Sarah. So at this point, T was equal to 2 hours. And so after 2 hours, then John would have went a length of distance of 75 kilometers per hour times 2 hours will be 75 times 10, uh, excuse me, 75 times 2, which is 150 kilometers that John traveled, while Sarah only managed to travel a distance of 60 times the same 2 hours, which was 120 kilometers. And then after this 2 hours, John decided to take a 90-minute break, while Sarah continued driving and eventually reached her destination after those 90 minutes. And so Sarah drove 90 minutes more to reach the finish point. And so if there was an extra 90 minutes of Sarah traveling, that's an extra 1.5 hours of driving. So if we multiply 60 by 1.5, then we get 90. So Sarah traveled an extra 90 kilometers. And so she was already at 120, but then if she traveled 90 kilometers more, then she would be at 210 kilometers. And so this total length from start to finish will be 210 kilometers. And then now, after John's break, so let's take a look back at the question one last time. After John's break, how long would it take in minutes for John to catch up to Sarah? And so because Sarah's already at the finish point, she won't be moving anymore. And so John, who is at 150 kilometers right now, would have to travel a total of 210 minus 150, an extra 60 kilometers. And so we divide 60 kilometers by 75 so that we get uh, this, this many hours of traveling. So if we simplify 12 over 15, which can be simplified even more to 4 over 5 hours. But then because the question asks in minutes, we multiply by 60 minutes per hour so that we can divide hour. And then if we multiply 4 over 5 with 60, we simplify to 12 and get 48 minutes of extra travel for John. And so it kind of a uh there's multiple topics and multiple concepts that are utilized for this question, and ratio being a small part of it, but still incorporated. So I wanted to kind of give you a taste for what future concepts could hold, such as unit conversions from different units of time. And so that will be wrapping up our final question. And so, does anybody have any questions for this one? It seems like none. And so I will be wrapping up our class here. And so we can go all the way back. There was a lot of concepts for today's class. And so I do recommend taking a look back at it once or twice just to kind of fully understand every single concept and to master it so that later on when you're taking the SAT, you'll be much well prepared. And so that'll be it for today's class on ratios. I will see you on Thursday for unit conversions. And so, yeah, that'll be all for today's class. Ooh. And then, yeah, so I will be seeing you on Thursday. So, once again, thank you so much for listening to and participating in today's class, and I'll see you next time.